it's a little bit strange actually, because we're doing lots of small chapters in semester 2. So permutation and combinations was only 2 lessons, and this next chapter is also only 2 lessons, and then the next chapter is 3 lessons. So there's lots of small chapters in semester 2. So this new chapter is called the binomial distribution. Probability for this one, yeah. Malik, we have one more probability chapter to do after this, and again it's small, 3 lessons, and then that's the probability part finished. Then we're on to calculus. Yeah. Okay, sorry, have you got this title? Binomial distribution. Yeah. Okay, so let's have a look at a small example. So remember, let's say we have 3 people voting. So for example, we have, yes, yes, no, whatever. So we have 3 people voting, and we want the probability of getting 2 yeses, for example. How many combinations are there if 3 people are voting? How many combinations? What do we... Yeah, it's 3, C, 2. Yeah, so there's actually 6 possibilities. So it could be yes, 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 no, yes, no, yes, yes, no, 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 yes, yes. Wait, hang on.
No, yes.
No, it's yes.
No, yes.
Oh,
You had it before.
well, I've done something wrong. Oh yeah, we don't care about the order. So you could have one person vote yes. So you could have yes, no, no. Or you could have no.
Yes, yes.
I'm tired. Yes, yes, no. Yes, yes, yes. Yeah, this is what's confusing me as well. 3C2 is not 6. What is it? 3. Now everything makes more sense. So you could have yes, no, no. Well, I suppose you could have no, 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 yes, no, no, yes, yes, no, yes, yes, yes. What? No, forget it. I'm getting very confused. It is right. But that's that's not the point I'm making, so sorry. Right, so here we want 2 yeses.
Yeah.
So there's 3 ways to do that. So you could have
Yes, yes.
yes, yes, no. Yes, no, yes. No, yes, yes. So these are the 3 ways you can get this. Thank goodness. So there are 3 ways to get 2 yeses. But when 3 people vote, how many possibilities are there? When 3 people vote, how many possibilities are there? So this is only 3 possibilities, but of course there's more than 3.
27.
Is that much? Yeah, so when 3 people vote, how many possibilities are there?
8.
Well, we could write them out. That's what I was actually doing at the start.
8.
Go on, Tony, tell me them. Start.
2.
Yeah? What's the first possibility? Yes? Yes, yes.
Yes, yes, yes.
Okay. Yes, yes. No. Yes. No. No. You know what? Forget it. This is. I was in my head. I'm like, I'll do this, and it'll be easy. And now I'm thinking, why did I decide to do this? I'm not doing this. I know. This is what I'm stopping. So, wait 1 second. Sorry.
We don't need all that.
Okay, that's
Oh,
right.
can hear you. We're going to look at binomial distribution. Let's start again. So binomial distribution. So firstly, when do we have these types of problems? So this is when we want the probability of or yeses or successes or whatever we're counting from a group of n. So I'll give you some examples. So some examples would be, the probability that 3 people vote yes from 10 people. Or for example, they probability score 2 goals in 5 attempts. Can we think of any other examples? So when you want the probability of so many successes in a group. So this is voting yes, this is goals scored. Anything else? Yeah, good one, yeah. So maybe I want the probability that 5 students pass in a class of 10. These are the type of examples we're going to look at. Yeah? Yeah? Okay. Can I go down? Can we think of maybe a business or economics example? I guess voting would be one, but what about in manufacturing? Any examples?
It's like when you have when you're manufacturing products, like
Yeah? Go on.
you might have a percentage of good products and bad.
Faulty products would be one. So you might say, what's the probability that there will be one faulty product in a box of 10, or 20 or whatever. So examples like this. Okay, can I scroll down? Yeah? Yes? Okay, so let's try this number thing again. But to make it clearer, I'll have 3 people. So I have Malik, Tony, and Pony. They're voting on something. And I want the probability that the vote will get 2 yeses. So the 3 of them are voting on something. And I want to know the probability that 2 of them will say yes. Okay? So we have Malik, Tony, and Pony. So let's write them down. Malik here, Tony here, and Pony here. So first, I'm going to list all the possibilities, and then I'll just pick the ones I care about. So we could have, they all vote yes. Yes, yes. And then we could have, then Pony votes no, and then we could have yes, no, yes, yes, no, 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 yes, yes. Got a bit crooked. Yes here. No, yes, no, 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 yes, and then no, no, no. So let's see, how many possibilities do we have here? 1, 2, 3, 4, 5, 6, 7, 8 possibilities.
But the order matters.
We'll get to the order part in a moment, yeah. So for the moment the order matters, but soon it won't matter. How many of these possibilities do I care about? Which are the ones I want? Which are the ones that have 2 yeses in them? Well, the first one, no, because that's 3 yeses. This one, yeah, yeah, no, yes, no, no, no. So there's only these 2 here. Yeah, there's no other one, but I didn't miss. Oh, 3. Sorry, 1, 2, and 3. So the probability that I'll get 2 yeses, that's the probability that I'll get yes, yes, no. Or, what's the next one? Yes, no, yes. Or, no, yes, yes. So I don't know if you remember this from semester 1, but when you have it like this, you have to add them together. So the first one is probability of yes, yes, no, plus probability of yes, no, yes, plus probability of no, yes, yes. Now, let's just say that Malik, Tony and Pony, the way they vote yes or no is very simple. They take out a coin and they flip the coin, and if it's heads they vote yes, and if it's tails they vote no. So let's have a look at the first possibility here. So what is the probability that Malik will vote yes if the way he votes yes is by flipping a coin? It's a half, isn't it? And then what's the probability that Tony will vote yes? It's a half as well. And then if for Pony to vote no, it's a half as well. Now, if you didn't know the probabilities, so for example, maybe they didn't flip a coin, maybe they rolled the dice. And if it's 1, 2, 3, 4, 5, they vote yes, and if it's a 6, they vote no. So in that example, what would be the probability that Malik votes yes? 5 over 6, and then Tony, 5 over 6, and then Pony, over 6. So rather than putting in numbers, I'll just put in letters, okay? P will be for yes, P is for yes, and Q will be for no. What would be the next one? P, Q, P, and the last one? Q, P, and P. But you notice that these are all the same, because this is P squared Q, and this one here is also P squared Q, and then this one here is also P squared Q. So I have 3 P squared Q. Now, actually, we've seen the number 3. The reason that this is a 3 here is because there's 3 possibilities. But we learned in the last class how to work out how many possibilities there are. So if you have a group of 3 people and you want to choose 2 of them voting yes, how many ways is that? 3, see 2. So that's the reason it's 3 there. Why is the power 2 here? Because you want 2 yeses. And why is there a power 1 here? Because you want 1 no. So in general, if you want, for example, or yeses from n people, the rule would be n, c, or p power, what power would I have here? In this example, r. And then for the no's, n minus r. So this is actually the formula we're going to have a look at today. This is the probability for whatever number of yeses from a group of n. You can find it out from this formula. And of course, what does Q equal? How can I find Q if I know P? 1 minus P, of course. Yeah? Sorry, that's what I was trying to do at the start. I don't know why. Probably because I didn't have my coffee yet. Let's put in some numbers as an example. So in this example here, let's say we have 3 students roll die, and I want the probability that 2 of them get a 6. So we'll write down the information. N is how many students, so what's N here? Try again? 3. R is how many successes I want. How many successes do I want here? 2. P is the probability of 1 success. What's the probability of getting a 6? 1 over 6. And Q is the probability of 1 failure. What's that? 5 over 6. So this one here, it would be 3C2, 1 over 6 power 2, 5 over 6 power 1. So let's have a look at that. That equals 5 over 72. 0.0694. Okay, so this is our first example of using the binomial distribution. Yep. Okay, can I go down and do another example? Yeah. So let's say here we have our goalkeeper. Yeah. And oh yeah, it's fantastic. And here in penalty shootout, there's 5 shots, and I can't remember, but I think each penalty is pretty likely that he or she should score. Anyone want to give me what they feel is a good number for the probability of scoring a goal? Oh, no, better than a half. Yeah, maybe not that good. Maybe more like 3/4, something like this, yeah. So my question is, he shoots 5 times. I want you to tell me the probability that he will score 3 goals. Okay, so I want everybody to try and calculate this. Yeah, can you calculate? Do you know what to do, Marcelo? No? So first write down what each letter is. N, R, P, and Q. So what's the N? It's 5. Why is it 5? Because there's 5 attempts. The R is 3. The P, 3 over 4. And the Q, 1 over 4. And the formula is NCR, PR, Q, N minus R. So if we just type that in on the calculator. Alright, what answers were people getting here? Yeah, that's it. This is 26% chance. Okay. Can you give me also now the probability that he scores 4 and then the probability that he scores 5? Okay. Scores 4. It's 405 over 1024. And then for scoring 5, two, 4, 3 over 1024. Did you get this? Yeah. Yes? Okay, so the reason I asked you to do the 3, the 4 and the 5, are we okay? I see people still using their calculators. Do you know how to use it? Yeah? Okay, so the reason I did 3, 4, 5, Pony? Question, yeah? You sure? Yeah. Tony? Yeah. So, for example, my next question could be probability that they score 3 or more. So if you score 3 or more, that means you want the probability that you score 3 or 4 or 5. 5. Exactly. So what you do is just add these 3 together because we already calculated.
These are what I was saying like yesterday. When it's or, you add.
I can't even remember what you said yesterday. Yeah.
If it's and, you multiply it or you.
Yeah, that is true for this lesson. Yes. But that was not true yesterday.
Yeah.
Was it? Yes, okay, alright, yeah.
More or less.
Alright, so 135 over 512 plus 405 over 1024 plus 243 over 1024, and you get, yeah, pretty high, 90%. So there's a 90% chance he will score 3, 4 or 5 goals. 0.89, something like this. Okay. Can I scroll down? Yeah? Okay. Come on. Alright. So let's say we'll go back to 3 people vote. So there's 3 votes. And the probability of a yes is, let's say, a half. So I want the probability that the vote will pass. Okay, I'll give you a minute to try and calculate this, and think about it.
All of them pass?
No, I want you to try and figure out what I mean here, that the vote will pass. What do I mean, or what do you mean when you say a vote will pass, that the vote passes? Yeah, it means a majority. Yeah. Hey, are you speaking Chinese again, Albert? What are you saying? 3 people voting. And it's 3. Yeah? There are 3 people voting, and I want to know what's the probability the vote will pass. So what's the probability that you get a majority of the 3 people saying yes? So how many people need to say yes? 2 or 3. So this here is the probability of 2 yes or 3 yes. Yes? Wait, stop, pause. So, are people calculating this and calculating this and adding together? Yeah? Before you do that, there's a quicker way here. This is the same as 1 minus the probability of not 2 or not 3. So if I don't get 2 and I don't get 3, that means I got 1. Or 0, I suppose, yeah. So actually it's not really quicker. It's the same as 1 minus the probability of 0 yeses or 1 yeses. So I should have made this a bigger number, but it doesn't matter. Sorry, continue with your adding. So that's 3C2, a half power 2, a half power 1, plus 3C3, a half 3, a half 0. And the total here? A half. Half, yeah? Oh, recalculate. Okay, let's do another one like this. So this time I want the probability that I won't make it too difficult, that no one votes yes. And I'm going to change it, this time make it be 10 people, please. But we'll keep the probability the same of voting yes. P is a half. Q is a half. No one votes yes. No yeses. So, if no one votes yes, how many yeses? That's 0 yeses. So that would be 10C, 0, a half power 0, a half power 10. This is very, very small, isn't it?
1 over 1024.
Okay, that's not too small, I guess. It's pretty small. That's okay, isn't it? This is no yeses. Alright, now try this one. Probability of... What's wrong? You can ask me, don't be shy. Question? Are you sure? I like answering questions. They make me feel good. No? How to calculate which one?
No, I think it was 10 people vote how many probability?
10 people, no yeses.
10 people vote how many probability? Total probability.
10 in total.
Yeah. That's
Say again?
like actually how you get 1 over 4.
Oh, how do I get one up? Well, that's what Malik told me. I hope he's right. 10, see...
It's right.
Okay, so then what's the problem?
10 people vote.
10 people vote.
Yeah.
How
many total probability?
the probability
Is 1 over
1 over 1024 that nobody says yes, that there's 0 yeses. Yeah? So here I want no yeses, or if you prefer, Tony, you can think about it like this as well. No yeses and 10 no's. This is what I want. So this is not very likely, because if each person has a 50-50 chance of voting yes, if all 10 of them say no, that's not likely. That's like you flip a coin 10 times and you get 10 heads. It's not likely. This is why it's so small. Yeah? Okay, try this one for me. What about if I said at least 1 yes? At least 1 yes. Okay, let's have a look at this, because there's two ways to think about it. So at least one yes means the probability of one yes or two yeses or three yeses, etc. That's a lot. But you could change that into 1 minus the probability of not one yes or two yeses, etc. So if I don't want one yes, two yes, three yeses or four yeses, that's the probability of no yeses. Does this look familiar? It's what I asked you to do a minute ago. So that's 1 minus 1 over 1024. So that's 1023 over 1024. So you see, it's very likely that at least one person says yes, that you have one or more yeses. Yeah? So what I want you to do for me now, if we go back to our football player, what was his probability? It was 3 over 4, and his N is 5 shots. So I want the probability that he will score at least one goal. Okay, try this one for me. Did we get an answer? What did you guess? Let's see. Share. What did you get? Show me. I know my answer's right. I want to know if your answer's right. Turn it. Let's see. What did you guess? Decimal and fraction. Okay, that could be right. I know that is right. I think that's right. Right. We got an answer? What did we get? Same as the last one. That's just an accident. That's a complete accident. So, probability scores at least one goal. That's 1 minus the probability that he does not score one or more. So if you don't score one or more, how many did you score? Yeah, you scored 0. Yeah. Score at least one goal. 1 minus the probability he does not score one or more. That's 1 minus the probability that he scores 0 goals. 1 minus 5C0, 3/4 power 0, 1/4 power 5. So these are 0 goals, and this is 5 misses. And I think this comes out as, by accident, the same answer as the last one. So there's a 99, is this 999, isn't it? There's a 0.999 chance that he'll score at least one goal. And that makes sense. How many football games have you seen where, of the 5 penalties, all 5 of them are misses?
My team.
Your team? Who's your team?
Football.
The team you pay for? Oh, okay, alright. That's happened? Yeah. Once?
Brothers do as well. like twice.
Twice? Wow. Okay, so their P is less than 3/4 then, maybe. Okay. Let's do one that's a bit more difficult now. Can I scroll down? Yeah. Right. So again, since we're talking about the footballer, we'll stick with the footballer. Again, 5 shots, and again, P is 3/4. And this time I want the probability that, let's say he scores twice, and his last shot is his second score. So what I want here is let me explain. He scores twice, but his second goal he gets it on his last attempt. Now I know it seems similar, but in this case the order matters a little bit. That you want him to get 2 goals, but you want the first goal to be in the first 4, and where must the second goal be? In the last one. So if I draw a little picture here, what you want is 1 goal in the first 4, but the second goal must be in the last one. Yeah? What do you think? Oh, it sounds like you have an idea. Come on, don't be shy. No? Okay, alright. Yeah, so the way you think about this problem is, here, yeah, this is a n equals 4, you want 1. And this here, well, not half, is 3/4.
3/4.
Yeah. And Victor, add or multiply the 2 answers. Oh, you're not Victor. You see, I wanted to see if he could get it. Well, do you agree? Multiply or add? Are you sure? Okay, you're right, yeah, multiply. Right, so if we look at the first 4, what would that be? 4C1, 3/4 power 1, and 1/4 power 3. And then this we multiply by the probability of a goal on the last one, which is 3/4. Yeah. For the last one? Yeah, because this is just 1 goal by itself, and we said in the question that a probability of scoring any single goal is 3/4. Alright, give me an answer here.
9/256.
What did you get? Correct, yeah. 9/256. If you put this in the calculator. Does your calculator have the C button on it?
Yes.
It does, okay. Can I scroll down? Yeah. So let me give you another one like this to try. We'll use a deck of cards since you're tired of this footballer, I know. Right, so we have our deck of cards. And how many cards in the deck? 52. So you take a card out, but importantly, you put it back in afterwards. So you take out, we'll make it 4 cards. So you draw 4 cards. But don't, again, every time we put the card back, okay? So I want the probability that you get exactly 2 aces, but the second ace happens on the last draw. Is on the last draw. So we take out 4 cards. I want 2 aces, but the second ace happens the last time you draw. Yeah, how many aces? 4. You don't play cards then, Malik, no. So an example, would be something like no ace, ace, no ace, and you must get ace at the end. So the first half is a 3 choose 1 problem, and then the second half is just a simple what's the probability of getting an ace. So what is the probability of getting an ace? 4 over 52. So the answer would be 3C1 times 4 over 52 power 1 times 48 over 52 power 2 times 4 over 52. Let's check. Let's put as a decimal 0.0151. Yeah? We got that? Yeah? Okay. Let's do one a bit more difficult now. Right. So for this one, how many eggs in a dozen? There's 12 eggs in a dozen. Let's say the probability an egg is broken is, I don't know, 1 over 12, let's say. I think that's reasonable. Right, so my first question, what's the probability that there's at least 1 broken egg in your dozen? So you don't want this, of course. You don't want a broken egg. So what's the probability that you get at least 1 broken egg? Okay, what do we get here?
140.
As a decimal? This is 1 minus the probability that there's none broken, which will be 1 minus 12C0, 1 12 0, 11 12 12. and this is 0.648. So, if the dozen eggs has at least one faulty egg, if the dozen eggs have at least one broken egg in it, then we call the dozen faulty or broken. You know, you don't want to buy eggs where one of them is broken, so we'll call this this dozen is faulty. You probably know this word from business and economics, faulty. Okay, so next part of this, next half, B. So does anybody know what a gross is? And I'm sure some people are thinking disgusting. It's not the meaning here. So the other meaning of gross. Does anyone know? I feel like I've asked you this before. And not only do I feel like I asked you this before, but I also feel like the last time I asked you, I also said I feel like the last time I asked you before. So I think I might have said this word 3 times. This is what you sure? I really feel like this. Are you sure? Nobody remembers. Alright, anyways. Does anyone know this word gross? Gross is 12 dozen. So it's actually 12 by 12 eggs. So if you picture it, a gross is 12 dozens of eggs. 12 dozen. Okay, so now my question is, what is the probability that you have at least one faulty dozen of eggs? Try this one. Yeah? Any answers? Same way, but different numbers. And I'm not telling you what numbers to use, but it's the same idea. No? Okay, let's have a look at it. So just like with the last one, at least one faulty dozen. That's 1 minus the probability that none are faulty. So that's 1 minus. Now, how many dozens do we have? We have 12. And how many do we want faulty?
But you cannot have like 11 and 9. Exactly one.
Yeah, at least one is faulty. So 1 is broken, or 1 is faulty, 2 is faulty, 3 is faulty. And I'm saying that's 1 minus the probability none are faulty.
Okay.
None of those 12. So 0 faulty, all 12 are perfect. So how many do I want faulty here? What number? 0. Now, this is 0 faulty and then 12 faulty. What's the probability a dozen eggs will be faulty? It's what we just worked out. It's 0.68 648. So therefore, what goes in here? Try again. 648. So this would be 263? 0.632?
No.
No.
3,
352. Yeah, of course. Right, so what does this come out as when you calculate it? It's a lot of nines. It's practically 1. How many nines do we have? 1, 2, 3, 4, 5, and a 6 after that. I should round this to 1.
the same idea when you are multiplying.
Mm-hmm. Yeah. Now the reason I did this one is they like this one in the exam because you have a binomial distribution problem and it's like it's inside another binomial distribution problem. So the first one we had was a dozen eggs, and then this was like it was in a bigger problem. They like this one in the exam. That's why I wanted to do it. Okay, last thing, and then I'll let you try some. So let's imagine we have 100 cars, and we'll say the probability that there's something wrong with the car is 1/20. So I want to know what's the expected number of broken cars. So if I have 100 cars and the probability is 1/20 that the car will be broken, how many broken cars do I expect in my 100? Yeah, how'd you get 5? It is 5. Yeah, 100 multiplied by 1/20. So my formula here is the expected value of yeses, successes, whatever. The formula is a very simple n multiply p. But you could have guessed this formula. It makes sense, you know. If I have 12 eggs and probability is 1/12 that it's broken, in 12 eggs, how many should be broken? 1. I mean, it makes sense. What maybe doesn't make sense is what might be the formula for the variance. I don't know if anybody knows it. Oh, so close. NPQ. So if we just take our 100 cars again, what would be the variance? Let me see, that would be 100 times 1/20 times 19/20. What's that now? (19/4). Yeah? So the square root of the variance is 2.18. How many cars did we expect to be broken? 5 cars. So what I'm saying is we're expecting 5 cars to be broken, but there's a bit of course, movement. It could be as little as, maybe about 3 cars, but it could be as much as maybe 7 cars, roughly. That's what we mean by the variance, the spread. Of course you could get more than 7 cars broken, and of course you could get less than 3 cars broken, but they become less likely. So most likely is that 3 to 7 cars are broken. Okay. Now what we'll do is I'm going to let you try some of these for a few minutes, and then what I want to give you is a past exam. I want to show you what some of these questions look like in the exam. So I'll say, we'll do this for a few minutes, and then we'll have a look at past exam. What's wrong? No. And so it's interesting because this topic is on the Irish high school, and of course it's on your program. But different programs like different types of questions. So the questions that they really like asking you are the ones I did with the eggs, where they have eggs and then there's eggs in a bigger box of eggs. Okay, can you try these for a few minutes? And I want to circle some maybe important ones. There's 4 questions I want you to do now at least, and the rest you can finish at home. So the 4 I'd like you to do now for practice is 1, 3, 6, 10.